In the endless darkness of the cosmos lies a riddle far older than humanity itself. A vast and ever-expanding universe, one that holds secrets stranger than any science fiction. For centuries we believed the universe could be fully understood. That with better tools and better theories, everything could be explained. But today, even the most brilliant minds are left speechless. Recently, the most powerful telescope ever constructed, the James Webb Space Telescope, uncovered a discovery so shocking it may overturn everything we know about the origin of the universe. An invisible event has unfolded on a cosmic scale. Over 900 trillion stars have seemingly vanished, without explosion, without light, and without trace. Launched in late 2021 and fully operational since July 2022, the James Webb Space Telescope was designed to exceed the capabilities of Hubble. It peers deeper than ever before, capturing ancient light stretched by time and space, light that began its journey billions of years ago. This light is not merely distance, it's history itself. The telescope observes the universe as it was, not as it is. Its goal? To capture long-wavelength radiation from ancient galaxies, light that has been redshifted far beyond the visible spectrum. In doing so, it revealed something entirely unexpected. Whole regions of the sky, once believed to contain countless stars, now appear dark. Not obscured, not dim. Simply gone. How could hundreds of trillions of stars disappear? Where have they gone? There are two primary possibilities. The first suggests that these stars still exist but are now hidden, either by cosmic dust, or because they faded into darkness, collapsing into black holes without the expected supernova. The second possibility is far more unsettling, that this is part of a larger phenomenon. That the universe itself is entering a phase of vanishing. A slow erasure beyond our control. Since the early 20th century, astronomers have known that the universe is expanding. Not like objects flying outward, but like space itself stretching, pushing galaxies farther apart. Then, in 1998, came a stunning realization: this expansion is accelerating. Driven by a mysterious force we call dark energy. Galaxies aren't just drifting away. They're being pushed faster and faster, until eventually, their light can no longer reach us. When observing galaxies, we often talk about how long their light has traveled. But a galaxy whose light took 100 million years to reach us is actually farther than that now, because the space between us expanded while the light was en route. This cosmic stretching shifts the light's wavelength, producing what's known as redshift. The farther the light travels, the more it shifts. This redshift is evidence that the universe is not static. It confirms that expansion is real, ongoing, and accelerating. By measuring redshift across different distances and comparing the intrinsic brightness of those objects, scientists can reconstruct the universe's expansion history. What powers that expansion is determined by what the universe is made of. Current models estimate that around 68% of the universe is made of dark energy. 27% is dark matter, undetectable by light, but measurable through gravity. Only 4.9% is what we know: stars, planets, atoms. The rest, neutrinos, photons, and other particles, make up less than a fraction of a percent. With this understanding, scientists can use Einstein's general relativity to predict the universe's fate. Dark energy dominates. Galaxies that aren't gravitationally bound to us will keep drifting away. Eventually, they'll move so far, so fast, that light from them will never reach us again. But of all the galaxies it contains, only around 6% are accessible to us. 94% of the galaxies in our observable universe have already crossed a threshold. Their light, emitted today, will never reach Earth. Between 20,000 and 60,000 stars become unreachable every second. The light they emitted in the past may still be traveling toward us, but any light they emit now will never arrive. This realization is sobering. It means that every passing moment is a lost opportunity to explore or communicate with the greater universe. Our cosmic neighborhood, the local group, is made up of the Milky Way, the Andromeda Galaxy, and around 60 smaller satellite galaxies. Beyond this gravitational bubble, everything is retreating. There are an estimated 2 trillion galaxies in the observable universe. But only a tiny portion remain within reach. Unless we discover a way to bypass the limits imposed by dark energy and cosmic expansion, humanity will remain confined to its small corner of space. Our ability to explore, to reach out, to learn from the cosmos, is slipping away. And the expansion of the universe will continue, relentlessly. No force we currently know can stop it. As the cosmos expands and fades into isolation, what remains becomes all the more valuable. Every galaxy still within reach. Every star we can still see. Every photon we can still catch. They are the last whispers of a universe slowly fading from view. The further we gaze into the universe, the deeper into the past we peer. But now, what we see no longer just tells the story of how the universe began, it whispers of how it may end. As the James Webb Space Telescope continues its long watch across the heavens, it has begun to capture more than just light. It captures absence. Silence. A cosmic quiet growing at the edge of what we can see. Galaxies that should be there aren't. Stars that should still shine are gone. Every second, the universe expands. The very fabric of space stretches, carrying galaxies farther and farther apart. Not because they are moving through space, but because space itself is growing between them. This is not science fiction. It is the documented effect of dark energy, the invisible force that pushes the universe outward, faster and faster. It's as if the universe is accelerating into silence. In the earliest moments after the Big Bang, galaxies were relatively close together. Gravity shaped their formation, drew matter into stars, stars into clusters, and clusters into galaxies. But that early gravitational balance is now being overwhelmed. Dark energy has become the dominant force in the cosmos. Its effect is profound. Light from distant galaxies takes longer to reach us, and as it travels, space stretches that light, shifting it into the red end of the spectrum. For some galaxies, the shift is now so extreme, their light is fading into invisibility. We are losing sight of the universe in real time. Each moment that passes, more stars and galaxies become unreachable. The photons they emit now will never arrive at Earth. Only the light they sent millions or billions of years ago still drifts toward us, a ghost image of what once was. It's estimated that only 6% of the galaxies in our observable universe remain accessible. The rest are already beyond our cosmic horizon. Even if we developed spacecraft capable of traveling at light speed, we would still be trapped. The universe is expanding faster than we can ever move. It's like being on a raft in a river that flows faster the farther out you go. Eventually, nothing can be reached.